Assalamu alaikum warahmatullahi wabarakatuh. Welcome to ELET301 Signals and Systems. This is Dr. Yusuf al-Muallim, and I'm happy to introduce you to this course in the following presentation. This is an introduction to ELET301, which is Signals and Systems. Here we're going to see the course within the ELET program in YIC as per the study plan. Then we're going to discuss the grading policy and course plan. Then we just get an answer about what is signals and what are signals and what are systems. Starting with the YIC ELET programs, if you look at the instrumentation and control plan, and you find the course lying in the fourth year, second semester. And it is a prerequisite or a co-requisite for some courses. One of them will be the control, and then we will see this will be a prerequisite for another course, which is digital and signal processing. So control as well as the digital signal processing. So we're talking about control and communication. And also this will be responsible for fluid mechanics, heat transfer. So understanding this course will help you to understand the all following courses. If you look at electronics, it is a course that we're talking about, and it is again a prerequisite for few courses like digital signal processing and also the digital image processing as well as parallel processing systems as an elective courses. If you look at power, the course again appears in the fourth year, and the course is responsible for the control system analysis, the power system analysis, and power systems operation control. I totally agree that this is not a prerequisite, but understanding the systems in this course would help you in working out smoothly with these courses, as well as it is prerequisite for control from control side and system side. As a fundamental course, ELET301 it lay down very fundamental subjects and concepts in few fields in electrical or specialization of electrical engineering. The first one is communication. So you need this course to understand and work on communication. Again, you need to work on this course to work with control systems, and finally signal processing multimedia systems. Moving to grading policy and course plan, here is the grading policy that we're talking about. All these would be on the course theory class, and then the last 2 points would be on the project side as well as the lab side. In fact, it covers multiple subjects, starting from signals, then moving to the systems. And here we're talking about continuous systems and signals. Continuous signals and systems. And this also talk about time domain. So we're talking about continuous and time domain. After we finish this part, we will start talking about the frequency domain into these three sections. So here we're talking about frequency domain, but it is again on time on continuous perspective systems and signals. And the last part of this course, we will start discussing the discrete part of the course, therefore discrete. We will repeat all these concepts again in discrete perspective. So in the beginning, we're talking about continuous, and then at the last, we will move to the discrete type of signals and systems. Finally, just a rough idea about signals and systems. So what is signal? Signal is a function of independent variable. So one example of independent variable, it is time. And then this function or this signal represents a physical variable of interest. So if we are focusing or trying to understand one physical variable, and this physical variable, it has to be a function of independent variable. So like it will be f of x. So this is the physical variable like voltage. And this independent variable will be like time. So it will be the voltage as a function of time. So this is a signal. So a collection of data. And here are some examples. This is a continuous type of function of a signal, and this is a discrete type of a signal. So voltage and current in electrical circuit, it represents the signal example. Okay, what is a system? A system is a process that produces an output signal in response of input signal. So the process is a system which is a response of a signal. So here is the system that we're talking about. We have a continuous type of system and we have a discrete type of system. And those are the signals that we are trying to deal with. So this is the input side and this is the output side. So we can easily understand that there is a reaction or there is an interaction between the systems and those signals. That's we call it signals and system course. So another definition of the system would be a combination and interconnections of several components to perform a desired task. So if we want to perform a desired task, like heating something, so we want to put an input to it and we will monitor the output of this system. So like if we supply a voltage as an input and we are monitoring the temperature as an output, and the system would be our heater in the middle. So here are some examples of the system. This is a system which works as a filter or rectifier. So the input here is a voltage source as input, and the output here is again the voltage after rectification. So it was a full wave, and after rectification it becomes a half wave. So these sides having the signals in the input and output. So this is the output that we're talking about, and this is the input that we're talking about. So x as a function of t, y as a function of t. And this is the system which represents the continuous time systems as a box as shown here. Thank you for your time, and see you in the next presentation.